All right, so today we're going to talk about something called end behavior. And basically, all we're really asking for is what is happening to the graph at either end of the graph. So for example, if I look at this graph right here, I basically want to know what's happening here on the far left and here on the far right. Okay, and I'll explain. So we have right up here the general form that we're going to use when we talk about end behavior. So we're always going to look as x approaches negative infinity and as x approaches positive infinity. So whenever we do any question, we're always going to write this, and then we're going to write this. And then corresponding to that is we want to know what's happening to the y values. Remember, f of x is just a fancy way of saying y. And then this is what we're going to be filling in right here. Okay, so I think it's a little bit easier if we just go through an example. So let's look at this example right here. Okay, so it says as x approaches negative infinity. So you would always write that down. And as x approaches negative infinity, well, this is the x-axis. And approaching negative infinity means we're going to start here and we work our way toward negative infinity. So do you see we're working our way to the left? So this is basically saying, look at the left side of the graph. So here's my graph. I'm going to look at the far left, right there. Okay, so this right here, and I'm going to write it, refers to the left side of the graph, which would refer to this end. Okay, and then what this is asking is, what is y doing at the left end? So what is y doing here at the left end? Do you see this keeps going up and up and up and up and up and up and up? Okay, so then if it goes up, that means you're going toward infinity. Okay? All right, the more we try, the more this will make sense. So let's go to the next one. So then underneath here it says as x goes to positive infinity. Well, again, here's the x-axis. Positive infinity would be going in this direction, right? Going toward infinity goes to the right. So this is basically saying what's happening to the graph on the far right-hand side. So this is really the right side that we're looking for. So we're looking for this end. Okay, that's why it's called end behavior, because we're just looking at what's happening at the end. So if we look at this end right here, this is saying, well, what's happening to y on the right side of the graph? On the far right side, do you see that the y value is also going up, just like the left side is? Okay, so then the answer to that would also be infinity. Okay, all right, maybe a little shaky on this. Let's go to the next one. So if we look at this one over here, this says as x approaches negative infinity. So remember, going to negative infinity is going to the left. So we're looking at the left side of the graph. Okay, so I'm going to circle it, just this part right here. And so this is saying, look at the left side of the graph, what's happening to the y value. And look at the y value. It's going lower and lower and lower and lower. So that, unlike the first one, is in positive infinity, it will be negative infinity. Okay? All right. Let's look at the one below it. So it says as x goes to positive infinity. Again, positive infinity is going to the right. So this is asking us to look at just the right end of the graph. So here's the right end of the graph. And what is the y value doing? And you should see that that y value is going up higher and higher. So that answer is positive infinity. Okay, I hope that makes a little bit more sense to you. All right, so maybe you should try the two underneath and see what you get. So pause me, try them, and then turn me back on and we'll go through the answers. All right, so this one says as x goes to negative infinity. Remember, that's the left side of the graph. This way is negative infinity. So we're looking at this piece right down here. And then we just want to know what is y doing at this end. And y is going down, so our answer is negative infinity. Oh, that's an infinity sign. Here we go. All right, and let's look at the next one. This one says as x goes to positive infinity. So that's the right-hand side of the graph. Okay, so that would be this one right here. And do you see that the y value is doing the same thing on this side as the other side? So that would be negative infinity as well. All right, next one. So this is asking you to look at the left-hand side of the graph. This is the left-hand side of the graph right here. Do you see that your y value is going up? So your answer is infinity. And then when we look at this very last one right here, this is asking you to look at the right-hand side of the graph, which is this part right here. That's the right end, right? Okay. And I'm just going to circle that, and you can see what the y value is doing. It's going down, so that will be negative infinity. All right, why does it please make sure that you are taking notes in your packet and filling all of this in. If you did not do that, pause this video and stick it in your packet. Hey guys, I made a mistake. From here on out, when we are working off of the packet, my numbers that you're going to see on the following page are off by 1. So for example, when I get to the next screen, my video says that it's question number 24. In your packet, it's really question number 25. Okay, my 25 is your 26, and so on. All right? Okay, so at this point, you can see that I am going to start on the following page, which is page, I don't know what page number it is, but it has numbers 24 through 27 in it. And you may want to pause the video at this point, try these examples, then turn the video back on, and that way we can go through everything and see what the answers are. All right, so 24A. Actually, let me do that over in black, so I think it shows up a little bit better. Okay. So A says determine whether it is an odd or an even degree polynomial. So we can see that we've got 1, 2, 3 direction changes. So this will be an odd degree. Okay? All right, part B. It asks for the sign of the leading coefficient. Now, just remember, we've done this already. If we want the sign of the leading coefficient, whether it's negative or positive, all you really have to do is just look at the far right end, and since this is going up, then we know that we're going to have a positive leading coefficient. Okay, so that would be positive. All right, now let's talk about the end behavior. So remember, when we do end behavior, we want to be in this form. Okay, so remember, this is referring to the left side of the graph, and this is referring to the right side of the graph, and we're just looking at the end. That's why it's called end behavior. Okay, the left-hand side of the graph is over here, and we can see that that graph is going down, right? So our y value will be negative infinity. Then over here, this is asking for as x goes to positive infinity, so that's the right side of the graph. And what is y doing? And you can see that y is going up. So your answer here should be positive infinity. Okay, let's look at 25. 25A asks for whether it's odd or even. Let's count degree rather, odd or even degree. So we've got 1, 2, 3 direction changes. So that would be an odd degree function. Okay, we want to know whether the leading coefficient is positive or negative. So remember, just look at the far right-hand side of the graph. This graph is going down, so we are going to have a negative leading coefficient. Part C. So remember, same thing. We always want to go toward negative infinity, and we also want to look at where x is going toward positive infinity. And we just want to see what happens to those y values. I'm going to look at the far left-hand side of the graph. That's right here. I see that my y value is going up, so that's going to be positive infinity. Then I'm going to look at the far right-hand side of the graph. I see that the y values are going down, so that would be negative infinity. Okay, all right, 26. We want to know whether we have odd degree or even degree. Well, just see how many direction changes we have. We have 2 direction changes. So 2 direction changes are just going to be, going to make this function an even degree, right? Okay, B wants to know whether we have a positive or negative leading coefficient. Remember, when we want to find the leading coefficient, just look at what it's doing on the right-hand side of the graph, and this is going down. So that's going to be a negative leading coefficient. Okay, part C. We are going to look at, let's see, so we have as x goes to negative infinity, what happens to f of x? That's a negative infinity, sorry. And then as x goes to positive infinity, what happens to f of x? All right, so as x goes to negative infinity, remember that's just the left-hand side of this graph here. Do you see y is going down? We're going to have negative infinity as our answer. And then if we look at the far right-hand side of the graph, same deal. Okay, y is also going down there also. So we are going to have another negative infinity. Okay, 27. I'm going to have to squeeze this one in because it's way at the bottom of my screen. But we want to figure out whether that's an odd or even degree function. Let's count the direction changes. So we have 1, 2, 3, 4, 5, 6. So that's an even degree. Okay, and I apologize for the messiness. I'm going to just try to squeeze it in. So that's going to be even. Okay, part B wants to know whether we have a positive or a negative leading coefficient. Again, look at the right-hand side of the graph. It's going up, so we're going to have a positive leading coefficient. I'm just going to put a little plus sign just so I can save the space. I'm sorry. So you should write the word positive in part B. Again, all of this should be in your notes packet. All right, part C wants end behavior. So I'm going to do as x goes to negative infinity. Let's look at what happens to f of x. And then again, as x goes to positive infinity, what happens to f of x? Okay, so let's see. As x goes to negative infinity means look at the left side of the graph. Do you see that y value is going up? So that means we are going to be going to infinity. And then let's look at the right-hand side of the graph, right? Because this refers to the right-hand side. And when you look at the right-hand side of the graph, you see it's also going up. So your answer then for f of x would be that it's going toward infinity as well. All right, so I would like you to turn the page. I'd like you to do 28, 29, 30, and 31. Pause the video, work on those, and then the answers I'm going to post up in just a second, so pause the video. All right, so here are the answers for 28 to 31. Do me a favor again, take your time, look through these answers, check them with what you have. If you have any questions, you can ask. If you have Mrs. Paris, she's in the room with you right now. You can ask her. If you have me, you can ask me when I come back. But I think that they should be pretty self-explanatory. Okay, so check them out. And please fix any questions that you got wrong. Fix the answers. If you didn't finish something, make sure that you write all of this in your notes packet. Okay, so if you turn the page, we're going to look at number 32 and 33, and let's just kind of read this real fast. It says, identify the graph that has these characteristics. So as we go to the left, the y value is going up. Well, as we go to the left, the y value is going up here, so that could work. But this is not. As we go to the left, this graph is going down, right? So we're going to cross off that one. All right, let's look at the next one. As we go to the left, that y value is going down as well, so that's not going to be the answer. And as we go to the left on this last graph, we are going up. So both 1 and 4 so far fulfill this characteristic right here. So let's look at the next one then. As x goes to positive infinity, that's the right-hand side of the graph, which one of these two is going to infinity? So as we look at the right-hand side of the graph, which graph is going up? Well, that's not happening here, but look, it is happening here. So the answer is going to be choice 4. Okay, next one. Same thing. So which graph has the following characteristics? 3 real zeros. Basically, that just means that they hit the x-axis 3 times. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So nothing's eliminated yet. Let's go to the second bulleted statement here. So as x goes to the left, the y value goes down. So as x goes to the left, the y value goes down. That's what that's saying. So as we go to the left, let me get my pointer back. As we go to the left here, my y value isn't going down, right? So this is not going to be an answer choice. All right, let's go to the next one. As we go to the left, my y value is going down. That's happening here. I think I just went out of order, but that's okay. So we're good here. As we go to the left here, my y value is not going down. So this is not going to be an answer choice either. Let's look at the last one. As we go to the left, look, my y value is going down. So far, we've got these two. Let's look at the last bulleted statement. So then it says, as x goes to infinity, so as we go to the right, the y value is going up. As I go to the right, my y value is going up here, but it's not here. Okay, so the answer is going to be choice 3. All right, so if we look at the last question here, we should see, and it's question number 35, that they're asking which of the graphs, so we have one graph here, we don't have the actual picture, but we have the equation. We have a graph in picture form, another one in equation form, and another one in picture form. And which of the following has these characteristics? I personally think that I would like to know what this looks like, and I would like to know what this looks like. So if you want to pause the video, you're going to stop, put that into your y equals, and get a graph, and just sketch it off to the side. All right, so we're going to look at as x goes to negative infinity. So remember, that's going and looking at the left-hand side of the graph. We want to see y approaching positive infinity. So instead, in other words, rather, going up. So here, left side of the graph, this graph is going up. So we're good so far. Okay, now let's look at choice B. As we go to negative infinity, so in other words, this part of the graph here, is the y value going to infinity? No, it's not. So we can eliminate that choice. All right, let's look at choice C. Here's the graph of choice C. As we go toward negative infinity, that's the left side of the graph, is this graph going up? And yes, it is. And if we look at this one, we can see that as we go to negative infinity, this graph is not going up. So we can eliminate that one also. All right, so we're down to either A or C, right? So let's look at the last condition that they give you. So as x goes to infinity, in other words, look at the right side of the graph, and we want the y value to go down. So here, right side of the graph, that's not going down, but the right side of the graph over here is. So answer is going to be choice C.